All right, welcome back. Second video here. So we'll check out a couple more scenarios you might see with line plots. One of those other words that you're going to see is called outliers. And an outlier, it kind of sounds like what it is. If you think about baseball and someone that plays in the outfield, they're sort of on the edge of the field, right? They're away from most of everything else. And that's what an outlier is, something that's on the edge, in this case, of our line plot. So if we were looking at this graph of the number of oranges in a bag, you'll see that this one here says 10 and there's only one of them there. So they're all bunched in the middle here, and then there's a 10. So the 10 would be the outlier. That's the one that's kind of hanging out on its own on the edge. We call those outliers. And the reason why those are important, if you were digging into this data a little bit deeper, you might think, okay, well, what happened there with that 10? Did someone make a mistake and put too many in? Were they all really, really small? So they're maybe the same weight, but all 10 of those were very small, and so they could fit more in. So there's a lot of different questions we can ask. We use graphs like this and those sorts of ideas actually quite a bit when it comes to packaging and businesses. So let's answer a couple of those basic questions while we're here. And let's look at, okay, what's the most common number of oranges in a bag? Well, if you could count them all, it looks to me like seven is the highest. Just to make sure I can count them: one, two, three, four, five, six, seven. Yep. So seven is my most common amount. And then, of course, if we wanted to add up how many oranges there were total, we could add up those seven from there in one bag. So that'd be seven times seven. Then you would do the next one would be 6 times 4. Then we could do 5. How many fives are there? One, 2, 3, 4, 5, 6. There's 6 fives, so we do 5 times 6. Then we could do 4 times 2 because there's 2 of those. And then we can't forget about that 10. That's one thing about those outliers. They still count. So unless you're asked to not use them, make sure you put them in. And then we just have to add all these up. So we'd have our 49 here, 24, and 30, 8, and 10, and we could add all these up. So we'd have, let's see, that's 40, uh, 89, 97, so 121 would be, this is total oranges that we put into bags. And sometimes that's useful because if we wanted to know, let's say we wanted to put the same amount in each bag or as close to the same amount as we can. Well, we'd have 121, and let's say we had 6 bags. Okay, we could figure out how many I need to put into each bag. So that's one way to look at these models as well. All right, next time it's your turn. So let me flip to the next screen real quick here so we can see what we're going to be doing. You're going to be given a line plot here. This one is on the size of cockroaches. Pretty gross, but these are pretty cool. They're Madagascar hissing cockroaches. They're really, really big, as you can see in this. This is a picture of a person's hand and the size of them. So we had students measure these outside, and these are the sizes that they came up with. So you're going to be using that line plot to answer these questions. What's the most common length? What's the difference between the largest and smallest cockroach? And we have a challenge question here that says, Jamie said that twice as many students found a length of 2.5 inches as found 1 3/4 inches. Is she correct? So make sure you're using, when it says explain, we do some explaining as to why we think our answer is what it is.